Hey, what's up, viewer? Welcome back to this Pong recreation tutorial series. This is going to be the third and final video for using Unity's visual scripting graph to finally create all of the game behavior necessary for this Pong recreation. I did a bit of studying before I started this video, so I'm going to do my best to try and squeeze this down to much less than an hour. The last two videos were both over 50 minutes. So I'm hoping I'll be able to blitz through this much quicker than that to actually finish up everything that I would like to discuss for this particular video. It would have been a little easier probably to split it up into like 3 separate videos, but I already committed to doing 3 total. So I'm going to finish up everything in this video. Alright, so I'm going to get started then. Where we left off, the player had the ability to use all of their keyboard inputs. So they could come in here and move the paddle on the left and move the paddle on the right, and the paddles properly stopped at the walls using the physics system like they're supposed to. The player can also hit escape to pause the game and re-enter the game. From this point, we've got to add a few things. We've got to add the ball moving around. We've got to add the ball reflecting off of collider surfaces. We've got to add the ball interacting with the goals in order to add score, reset the ball position, and transition into the result state in the event the player or the opposition won. We also need to update the in-game UI to reflect the scores properly. So the first thing we're going to do is we're going to get the ball moving. So to do that, we will open up our game screen script graph. I tidied up moving the paddles using a few subgraphs, so that might look a little different. Also, really quickly, I'm going to organize these a little bit by holding Control, left click, and then dragging a box around this. And I'll come up here and change the name from group to, and I'll call this respond to keyboard inputs. Same thing up here, I'm going to hold Control, left click, drag a box around these. And this is going to be, so this is player toggles pause. That lets us get a slightly higher level view of multiple graphs. So now I'm going to come over here, and the easiest way to get the ball moving is going to be using the onStart lifecycle function. This allows us to set a velocity for the ball as soon as the scene loads. So we're going to go into our scene variables, and we don't have the ball set up yet, so I will type ball as a new one. Go to the type and select a game object, then come in to the selector and select the ball. Then I will left click drag the ball object out. Then I will click on the nodule, drag it over, left click, and I will type R2D for rigid body 2D, and I will say SV and find the set velocity node. This is going to take the ball's rigid body and set it to some kind of velocity. And for simplicity, 4.4 has been working pretty good. So actually, we'll set it to 5.5 because that'll make testing a little bit faster. And then we will say on start. And this is how we get the ball moving from the get-go. So real quick, I'm going to drag this over, dock it, undock it, so I can have it free floating out here. Now if I maximize, minimize, it's a little cleaner, so I'll close this. And I'm actually in play mode, so I'm going to exit play mode. And let me double check that. Okay, good. That did not revert my play mode changes. So if this works correctly, the ball is very simply going to go up and to the right diagonally. However, now that I remember, I did forget one thing, and that is that the ball doesn't have a rigid body or a collider, so real quick, I will add a circle collider, and then I will add a rigid body 2D. I don't know if this matters, but I will put the rigid body above the collider. And I'm going to tweak a couple stats. For one, we don't need gravity interfering, so I can set that to 0. The other thing we're going to do is we're going to drag the mass to as low as I can get it, which is 0.0001. That keeps the ball from acting as... It keeps the ball from transferring force into the other objects that aren't static. So now if we enter play mode, it shouldn't complain anymore that it was missing its rigid body, but now that we have a rigid body, the ball should move. And it is saying I'm messing something up here. So let me go back into the game screen, and I will very simply, I'm just going to reset this. So I'm going to delete it, go to the scene, grab, oh, I guess since I changed it, it's forcing me to actually make a new one. I didn't know it worked like that. So we'll just set that up again and grab the ball, now that there's new components. And we'll drag it in and connect it, minimize this, close the graph, and now for the third time, the ball should actually move upon entering play mode. And, alright, so it moved, but as you can see, it didn't actually quote-unquote bounce. It only hit it and then kept trying to move. So in order to get it to bounce, we have to do something called reflect its vector, which is essentially just going to mirror its angle. So to do that, we'll open this up. And I will start off by grabbing the callback we need to actually get this to work. Since essentially what we're looking for is every time the ball collides with another collider, we need the ball to check which surface it struck and then reflect around a certain direction. So in order to do that, we're going to use the onCollision enter 2D callback function. So onCollision enter 2D, we're going to be using the ball for the decider, and we need to take the collider, left click on the nodule, drag it down, and we need to say GameObject get name. And this is going to gather the name of whichever game object the ball has struck. From that, we have to determine the normal that the ball needs to reflect around, which is essentially the normal that is protruding from each of our surfaces. And the best way I've actually found to do that is I'm simply going to key it in a dictionary. So I'm going to make sure I left click over here in space, then right click. And I'm going to type capital A, lowercase o, lowercase t, dictionary. And I will go down here to ahead of time dictionary literal. This gives me the ability to essentially fill up an array that I defined early, or excuse me, a dictionary that I defined early. And the way this is going to work is the key needs to be a string that is the actual name of the surface. So the first surface will start with his roof. The next key is going to be player paddle. The next key will be the floor. And as you can see, I'm doing this in clockwise fashion, which leaves the last option to be the opposing paddle. Now these do need to be the exact game object names because it's bringing the game object name from the collision data, and it will key from that, so it's got to be exact. And the way we do that is we go down here to this nodule, left click, drag it over here, and we will come down to get dictionary item, and that is keyed by a string, which is the name, so we can just connect this here. This is now going to give us whatever these values are that are keyed in. And in this instance, in order to make those values the proper vector normals we need, we're going to make them vector 2s. So we'll come in here and say vector 2, vector 2, vector 2, and vector 2. Then we need to properly define the angles for the normals. And this is where I've been having a little bit of trouble because it's acting as if it's saying y is the first value, so it's acting like it's going on yx. For instance, if you are considering the roof, the normal it's reflecting around is 0, -1 because that's y pointing down. However, in order to make it work correctly, I wind up having to say -1, 0. And just to prove that and before I fill in the rest of this chart, just so we can test this first one is working properly. I am going to finish the rest of this graph here. So not only have we set up the keys, we've gathered the name of the collided object, and we've grabbed a new normal through a vector 2. The next thing we need to do is left click into space, right click, and type vector 2 reflect. And we're going to use the vector 2 reflection node to determine which direction the ball needs to now travel in. So we can set up the trigger port. The item we're getting from the dictionary is the normal. And then the relative velocity from the collision is actually the direction we're moving in. Alright, so and now we've seen everything light up, so the flow is actually correct. The last thing we need to do is, even though we've activated this reflect node, we haven't actually told the ball its new direction. So to do that, we need to grab the ball once again over here with the nodule, drag over here, left click, and we will say R2D for rigid body 2D, and we'll say set velocity. We will connect to the control port to trigger this, and then the new direction is in fact this direction. And that is the graph for reflecting the ball. So real quick, I will drag a box around this, and I will call this reflect ball on collision. Then I will minimize the graph, close the graph, and we will test to see if the ball accurately reflects off of the roof. And ta-da, it worked. And even though, like I said, even though it's not in the XY order, it's in like the YX order, which I don't understand why that is, but that's how it is. When you hit this, it has to mirror around what it is calling the x-axis. But the x-axis is this way. So mirroring around the x-axis left to right would do this, but it's not. It is in fact mirroring around this axis, which is in fact up and down, which is y. So I'm not sure if I'm messing up something there or not, but that is why it is defined like this in the dictionary. It's acting as if y is the first number, as far as I can tell. So to set up the rest of the collisions, we have to assume that the player paddle, for instance, needs to mirror around the quote-unquote x-axis, which is, in this instance, the second value. And the same thing for the floor. The floor is mirroring around the y-axis positively, though, so it would be 1. And then the opposing paddle mirrors around the quote-unquote x-axis, but it's flipping it around, so it's positive 1. And now if this is correct, what is going to happen is we can actually reflect the ball off of all four collidable objects in the game. So let this load up here, and so we are seeing it bounce off of the objects. However, as you noted there, it is not bouncing exactly correctly. It's got something going on that's a little funky. Every once in a while the ball like jitters out really hard. And the reason for that is because even though we're in the XY plane, the object still exists in the 3D space, so there's a Z plane. So what's happening is when the ball hits the surface every once in a while, it's rotating on its Z axis, which is throwing off its depth from the camera, but because of the perspective mode it's in, you don't actually see that difference, but there's a difference in it traveling through space. So the easiest way to fix those monkey things is to just come in here and freeze the Z rotation on the ball. So now if we come in here and give it another run, we will no longer have those weird artifacts. The ball is now very simply going to mathematically reflect off of every surface. Not too bad. However, notice that when the ball goes off the screen, nothing happens. So that is the next step for us to create, is actually scoring making the ball score points whenever it hits the proper goal. So to do that, we are going to drop down here to a new spot on the graph, and we have got to consider what we are trying to access for this. essentially what happens is the ball is going to run into one of these goals. And if we take a look, both of these goals were set to triggers, which means that the ball will pass through them. However, it will still register as a quote-unquote collision, but the technical name for that type of collision is a trigger. So inside of our graph, we are going to left-click and space to clear any selections, and we'll right-click, and we are going to say on trigger enter 2D. And from what? From what is the ball. So anytime the ball object winds up triggering something, not colliding, triggering, slightly different, we need to run a set of commands for determining which goal was hit and attributing the proper score. And this is very similar to how we did this last time. We will grab the collider nodule, drag over, left click, and we are going to say game object get name. And this is a little more straightforward because we only have two options and they don't have separate values attached to them. So the step I've been using here is to use something called a switch node, switch on string node. And when we select this and we set up this control flow and we use the name of the game object, or the name of the collided trigger, what's going to happen is we can select the switch node. We can go up here to cases or options and click the plus, click two pluses. We're going to add two options. One option is the player goal. Oops, for some reason it disconnected. And the other one is opposing goal. So this allows us to, and one other thing we need to do. If the ball hits a goal, what we want it to do is then reset its position to the center of the screen so that the ball can keep bouncing around. And that's actually pretty straightforward. We simply say rigid body 2D set position. Then we say that the object is the ball. The position 0, 0 represents the origin, which does happen to be the center of the screen in this case, which is where we want the ball spawning. So we'll leave that at 0, 0. And we will go from the first, since this is the first thing we're doing effectively, we can set the control port trigger like this. And then the next trigger is this one. So we'll fix that sequence. Now we have the switch set up. But let's just show you all that this worked properly. So we will close this real quick, save, hit play mode, and essentially if I let the ball miss the paddle, it will strike the goal and it should reset to the center of the screen, which is exactly what it's doing. So that's a good start. It is not scoring, however, so we will address that next, which is what we're doing with the switch. There's a lot of nodes that wound up getting repeated in here with a few keys for modularity. So the way we're going to address this is we are going to create essentially we're going to create one subgraph and use it twice with separate parameters. So to do that, I will left click and to do space to deselect, then I will right click, bring up the fuzzy finder, and in this instance we're going to go down to nesting and select subgraph. I will double click the subgraph, that will zoom in. I will double click the subgraph again, and that is going to open up the subgraph. Then I will jump up here to title, and we're going to give this some kind of name, which is, I guess we could just say ball. We can say ball triggers goal. It's pretty straightforward. And then inside of this graph, we have to do all the logic for making the ball actually score, save the score, update the UI, and it has to do some logic to figure out if either of the players has won. So the first thing we're going to do is click on this input node, and then go up here to trigger inputs, and we have to actually set up a way to trigger this node to run. So as for a key name for this, we can simply call this, I guess we can say ball triggered goal. Pretty straightforward. So then real quick, I'll back out by clicking the breadcrumber up here to go back to our game screen script graph. And I will select the subgraph and click Control Duplicate, move it down here. And then essentially how this works is I will drag from the player goal and drag to the opposing goal like this. So depending on the name of the collider, which will be either player goal or opposing goal, it is going to run this subgraph with separate parameters. We haven't developed those parameters yet, so let's go back into the graph. And let's consider everything we've got to do here. So the first thing we need to do is we have to actually increment whomever scored, the score for whomever scored. So to do that, we will go to scene, and we're going to take a look. And we don't have any variables yet to track score, so we're going to have to put those in. So as for new variable, we will say player score. That is going to be an integer value. Defaults to 0. And then for the second one, we will say opposing score. Same thing, it's going to be an integer value that defaults to 0. And here's essentially what you do. If you didn't use a subgraph, you would have to use essentially a lot of the same code over and over, or a lot of the same nodes over and over, but you would start with the difference being one of these. So instead, in this example, what we can do is we can remove one of them, and we can key its name using an input port. So I'm going to select this input. I'm going to come over here to the Blackboard, and I'm going to click this little nodule here, and that is going to move the variables Blackboard graph to the other side of the screen, and that's going to open up the ability to have more data on this left side in regard to these nodes and their ports. And the reason I did that is because when we select this input node, we have to add a data input to it by going here to data inputs, clicking plus, and we have to give it a name, and the name for the port is very simply going to be score name. And score name is in fact a string, and we will say has a default value, and we'll leave default value blank. But what this is going to do is this is going to give us the ability to actually enter a value from the outside of the subgraph. So now that we have that set up, we can assume that our score name is going to be whatever we decide on the outside. So even though I dragged the player score variable like this into the scene, effectively what this is doing is each subgraph that we defined will have a different name and is going to change depending on the selection between the player score and the opposing score value. So this is no longer a hard-coded node, it is actually variable depending on something outside of the subgraph. Now that we have the variable selected, player score or opposing score, the next thing we need to do is simply add 1 to it. So that's actually pretty straightforward. We'll left-click, right-click to open the fuzzy finder and type add, and then we will grab the generic math add node. We will drag the variable port down to A, and then we will click on the B nodule, drag over, and we are going to click integer literal. That gives us the ability to add whatever this number is to whatever our variable value was. And in this instance, each time the ball hits the goal, it's 1 point, so we can just say 1. And now that we've gotten the variable and added 1 to its value, this isn't technically an increment. Like in code, you can say variable plus plus, and it assumes that you're assigning its own value plus 1. However, in visual scripting, you have to formally tell it to actually assign its own new value. So to do that, we will go back over to the player score, and we will do a nifty thing called hold alt, and then drag the variable into the graph, and that is actually going to differentiate us with a set variable. Whereas if we only left-click drag, it is a get variable. So it's very convenient to just simply come over here, hold alt, and it will drag in a set variable node for us. Now that we have the set variable node, we're going to take the add input result and plug it into the result. And we also need to make sure that we differentiate the value by the score name again. So as you've seen, there's actually 2 places where we variabilized our ports. And as this is the first acceptable control flow node, we'll actually make sure to say that ball triggered goal and plug it into this port. So what this is going to do is anytime the ball hits a goal, the ball will now not only reset its position, but it is also going to add 1 to either the player score or the opposing score, which depends on the collider result returned. Even though the scores have been added, they have not been told to update the actual UI for the game. So to do that, we are going to have to go back into our nifty uQuery extensions and UI document visual root element options that we've done in other videos, specifically in the, which was it, the UI, specifically in the UI builder and the UI toolkit video. And that's how we're going to access the player scores. So to do that, I will go down into an empty space on the graph, left click to deselect anything, right click to open the fuzzy finder. And the first thing I'm going to grab is the, actually technically what I need to do is, this scene does not have a UI document saved as a variable, so the first thing I need to do is actually just create a new variable called UI document. And the type for that is of course UI document. And we are going to grab the UI document off of our main camera. Now I can drag this in to get that variable. And from this variable, I need to do something called UI document get root visual element. So I can type UI document get root visual elements. And that's the node I want. From this node, now what I can do is I can actually use our uQuery extensions helper methodology that we've done in a separate video to actually grab the score, the actual score visual element from our root tree. So I will type uQuery extensions, go down to the one that has a single class name option. I will drag our root visual element result into this port. Then I will pick the name of the object, which in this instance, once again, since we're using two separate subgraphs, we have to differentiate between the player score and the opposing score. And instead of doing that with two separate extensions and doing all the same code except for typing names separately here, instead what we're going to do is select our input port, and we're going to go to data inputs, and we're going to add a new data input. And that input is going to be score UI name. We will change the type to string, give it a default value so we can enter a value on the outside, and then we're going to plug score UI name into this name port. This allows each graph to handle its own UI access. It doesn't have to, we don't have to have two separate checks each time one or the other gore is scored upon. So now that we have this set up, the next thing we need to do is actually access the, and let's take it to double check real quick. If I close this and I open up our UI toolkit folder and jump into our game UI folder, or our game UI visual tree asset, and we take a look, okay, good. So I was just double checking that they're actually called opposing score and player score. Since they key on using these exact values, we have to make sure we type them in exactly correctly. So let's open up our game screen script graph again, full screen it. And actually here's a good way to show this. This one's not refreshing for some reason. So just delete it and I'll make it a new one here. Go back to the outside. And as we can see, we can actually enter score name and UI name. So in this instance for the player goal, if the player goal gets hit, then that means that the opposing paddle scored. So the score name will be opposing score. And the score UI name was the same thing, opposing score. So then we'll come down here and do it for the player, it's player score, and player score. So let's open up the graph again. This is going to query a result, but we haven't done anything with the query. What we want to do with the query is change the text value on the label visual element inside of our root visual tree. So to do that, let's grab our element, and what we want to work with is the UI elements label node. So I will left click on this nodule, drag over, left click again, and I will type label. And I don't actually see anything in here, so let's try this again. UI elements label. And what do you know? Nothing's showing up. If you've been paying attention throughout the series, you understand that the problem is that we haven't actually added the proper type yet to our settings. So we have to go to Edit, Project Settings, Visual Scripting, go to our type options, scroll down to the bottom, add a new one, open up the type, and the type we're looking for is UI elements label. UI elements label, and it's not showing up, so let me just type label in. And then go to the second option, which is Unity Engine UI elements. Then we need to regenerate the nodes. This is going to take maybe a split second, so give me a second here, I'm going to take a sip of water. Take 2 seconds to go. Check out my Patreon, I'd really appreciate it. Like, share, and subscribe to the video if you find the content I'm doing useful. And regenerate nodes is complete. Okay. Now that we have regenerated our nodes, we will full screen this again. And let's try this again. Select this nodule to grab the visual element, or excuse me, the queried visual element. Drag over, left click, and this time type label in. And now we have Unity Engine UI elements label. So what we're trying to do here is grab this label element, and we're trying to set its text value, not its name, because that's its own object name. We're trying to change its text value. So to do that, we will simply say label set text, and ta-da, we have a set text value. And the text we are setting this to is actually our score, the score post update, or the score post updating after the ball has actually struck the goal. So to do that, it would be really cool to just drag the variable straight into this. However, it was getting a little fidgety when I tried to do this. It was not converting it properly, so I wound up having to make an extra step in the center, and that is very simply to convert the integer to a string directly. So to do that, after I clear this, which to clear this I will left click on the nodule and then right click on the nodule to clear it. Then I'll left click on the nodule again, drag over, left click, and I'm simply going to say integer to string. This brings up an integer to string node, and I'll take the string result and plug that into our label set text. And then I also need to make sure I set up the control flow properly, which in this instance is to do the query, then grab the integer value to plug into the label. So now the label is queued from the outside by a key, and the variables are queued from the outside by a key. So instead of having to literally do basically this entire graph twice, we only have to change a couple strings on the outside using separate subgraphs, which is pretty convenient. Alright, so now if this works properly, both sides should score when the ball hits the goal. And if I hooked it up properly, oh, let's double check that I named them. I think I named, yes I did. Okay, so let's give this a shot. So first I'll test the opposing score. The score on the left should go up if I let the ball hit the goal on the right. And it does. And there we go. So now we're scoring properly. So now let's kick it to the other side and see, make sure the scoring is working properly over here. And what do you know, it isn't. So we have one little problem. For some reason the score is incorrectly scoring, it's not properly scoring for the, player. So let me open up the graph again and see what's up here. Let's see, player score, opposing score, on trigger, enter, get name, player goal. So it was doing this properly, but it wasn't doing, okay, so let's just do this. Delete this graph, and apparently what's happening is I have to, like, it's not updating a graph copy properly. Because it was doing it earlier where it wasn't updating this, so that's interesting to note. If you actually want to copy a graph multiple times, it looks like you have to make sure that the graph is completely finished, then do the copies. It wasn't actually working otherwise. So no matter how many times I study for these videos, there's always some kind of pitfall that manages to work its way in. So now that I've done that, assuming that's the issue, we should be able to get the player to score as well. So let's see here, if I send the ball over to the opposing side, okay, now it's scoring properly. So now let's send it back over just to double check that it's going to score on this side also, and yes it does. Okay, so that's everything. That was a really weird physics artifact. It bounced off like the corner and it didn't know exactly how to mirror, so that was kind of interesting to see that happen. So now let's open the graph back up. The next thing we need to do is, even though the game is keeping score, the game hasn't been designed yet to quote unquote finish the game at a particular score. We have to continue doing some work inside of our subgraph here to tell the computer when a player has won the game. So to do that, we have to take the score and we have to check if that score is equal to a win score. So to set up that win score, what we're going to do is go into our scene and we're going to create a new variable. And that variable is going to be called, what should we call this? We'll call this final score. In this instance, to make it test-worthy, just so we get it done quick enough, we'll just make it 2. So if the score hits 2 at any point, the game needs to transition into the results screen and congratulate the player on winning or losing. So let's drag our final score in here. And to compare the final score with the current score of this value, we need to simply use an equal node. So we will open up the fuzzy finder and we'll type in equal, and that brings up the logic equal node. We will connect the final score, which is an integer, so we don't have to convert it. And in this instance, it's still an integer, so we can plug it into A. And now we're seeing if final score is equivalent to the new variable. And that will be either the opposing paddle or the player, it will be either the opposing score or the player score, depending on which graph is actually used. Now that we have the score checked, we have to actually do something in the event that it is true that the score has matched. And to do that, we use the good old if node. So if in control, and we plug the result of this equal into the Boolean port. And in the event it's true that the score has been met, we need to go back to our good old load scene node and go down to scene, the one with scene name, and the scene name we're switching to is the result scene. And this can happen after we set the text to do this check. So now all the flow lights up. And while we're here, there's one more thing we should do, which is that once this occurs, if the player wins, it should say victory. If the player loses, it should say defeat. So essentially how this is going to work is before the scene manager loads the next scene, we need to save a variable that will go between scenes that will tell the result scene what the title should be. So to do that, we are going to click on the app variables, and we're going to add a new application variable, and we will simply call this result title name, and there's going to be a string value. And then we are going to hold Alt, and we're going to drag this into our graph because we need to set this variable before we actually change the scene. And in this instance, what do we want to change it to? Like I described, it's dependent on if the player wins or the opponent wins, which means we need to differentiate that by the outside of the graph. So we will select our input node. I'm going to click on this to drag it back over. It resets every time. There might be a setting for that. I'll need to figure that out at some point. And then we need to add a new data input string. In this instance, that is simply going to be result title name. It will be a string, and it will have a default value that we will enter. Then we will take result title name and we will plug it into this value port for the set application variable. So now from this, the title name variable will get set, and that is going to allow us to actually have the response we want on the result screen. So let's close this and save this. And real quick, I need to open up the result screen. And I need to open up the result screen script graph. I'm going to full screen this, and what needs to happen is, it doesn't need to happen on start. It needs, oh yes, it does need to happen on start. Okay, so essentially what we need to do, not too difficult, is once we're in this graph, click on the application variable, drag our result title name into the scene, or into the graph. And then what we need to do is query for the result screen result title, which I will double check by jumping into the UI result UI. and taking a look, and yes, it's called result title. So pull the graph back up, result screen graph. And essentially what I need to do is do another uQuery extension in here. So right click, open up the fuzzy finder, type in uQuery extension, go down to the proper node. The name of the query is for the result title. Let me full screen this. And we want the control flow to flow like this. And then it's using the same root visual element, so we can connect that like that. It looks like we can even drag this variable over here, drag this over here. And what we need to do is very simply grab the result title's name and set its name. So we've done that before. We click on the nodule, drag it over, left click, and we're going to say set name, label set name. Then we will set the label's name to whatever is the result title name from the previous scene. Oh, so then we have to set up this flow to flow around this. But this is actually going to allow us to set the proper name in the game scene when it's doing the scoring and determining who won. And then it'll simply load that result into the scene and set the label properly. So now we have that set up. If I switch back to the game scene and hit play, essentially what should happen is we should see the scores go up, and we'll let the opponent win first. And that, of course, is incorrect because, oh, you know what I forgot to do? Excuse me, I forgot to do one thing. I need to open up the game screen script graph, and I need to delete this, duplicate this, reconnect the ports, and then I need to actually make sure that I put the result title name. So if the opposing score is scored on, then that means that the player, or excuse me, so how this works, if the player goal is struck, then the opposing score goes up, the opposing UI score is updated, and in fact, if the opposing score achieves victory, then we have actually been defeated, so we will say defeat. By the same token, if the opposing goal is hit, then that means that the player score needs to go up. The player score UI element needs to get updated, and if the player score achieves victory, then we can actually say victory. Okay, so now let's close the graph again and shut this graph, and this time we'll give it another test. I will let the opposing score twice, and this should say defeat, and it did not. It in fact said victory. So I might be getting it backwards here. Let me open up the graph here. So if the player goal is hit, we want to set up the. Okay, let me see if the graph is like not hooked up properly. I mean, it should be set up correctly. Did I miss any flow? It doesn't look like it. So let me just test it. If, let's see, if I flip it around, let's see what happens if I flip it around. It should be saying defeat in that instance. So let me just bounce the ball over here and see if it just says defeat. So it also says victory here. So it's almost as if I'm not accessing it properly from the results screen, perhaps. Let me double check the results screen. And I mean, this is correct. I mean, oh, okay, so I screwed this up. I'm not setting the name, I'm actually setting the text. So set text. Text set text, no, we want to do label set text. Yes. Okay, my bad, I messed up. It's very easy to get those two confused, set name and set text. I'm pretty sure I even said to do that, and I did it anyway in a previous graph, so there you go. Alright, so now that that's set up, we might not have even had to come in here and mess with this. But if this works correctly, whenever the opponent scores on the player 2 points, it should say defeat. Okay, good, it does. So let's return to start. Let's run it again. This time we will actually bounce the ball to the other side and test the scoring over here. And this time it should say victory, and it does. Very good. Sweet. So that's effectively the game. You actually can play the game now, and you can have a different score from the other player, and it transitions you to the victory or defeat screen. There is one more thing we need to add for this project, and that is essentially this. If we get a game rolling here, and let's say the opponent has a score, or the player has a score, and the opponent has a score, like this, and then we choose to pause the game like this. When we go back into the game, the paddles should be in the same spot, the score should be the same, and the ball should be in the same spot. However, when we actually go back into the game, what we found is it has completely restarted the game, which is not how a pause is supposed to work. The pause is supposed to keep everything the same for unpause. So we have to deal with that. To deal with that, we need to come into the game screen script graph really quick. And actually, now that I'm in here, I'm going to tidy this up real fast. This, we're going to hold control and drag around this to create a group. And I'm going to change the group name here to, it's essentially ball triggers goal. It's the same name as the subgraph, but you just differentiate a little bit. We'll say ball triggers on goal. So now that we have that set up, in order to set up a way to retain all of the game data for unpausing it properly, the best way to do that is we have to save all of the relevant variables outside of the scene. And to do that, we can go into our Blackboard, and instead of doing scene variables, as we learned earlier, we can actually use app variables. So we have to define a bunch of app variables for saving the data, and then we need to save those data when we pause and reload those data when we unpause. So the first thing we need to do is start adding some new variables. So one thing we're going to need to save is the ball's position. So we will say ball position. That's going to be a vector 2. The other thing we need to save is the ball velocity, and that is also a vector 2. We will save the player paddle position, which is a vector 2. We need to save the opposing paddle's position, which is also a vector 2. And we need to save the player score, which is an integer. And we need to save the opposing score, which is also an integer value. And that will save, that's everything that can be variable on the screen. So the next thing we're going to do is, essentially what happens is this occurs every single time this scene loads, basically. Because what happens is the pause scene, when it unpauses, swaps back in to the game scene. And when that happens, it's going to run our onStart. So what we can do is take advantage of the onStart node here, and we're going to add a new subgraph to handle doing this part. So I will left click to deselect, right click to open the fuzzy finder, go down to nesting, and select subgraph. Then I will double click on the subgraph to zoom it in, double click on it again to open it up. And what we have to do here is we are, and actually this, I'm actually going to real quick change the, if it will allow me to. Oh, okay. So deselect, and then I'm going to change the title. And in fact, the first thing we want to do, I guess I can just keep it simple. So in this instance, what we're saying is load game data on unpause. And in order to load this data, what we have to do is grab all the data. So we want the ball's position, we want the ball's velocity, the player paddle position, the opposing paddle position, player score, and the opposing score. And we need to more or less very rotely apply all of these to the scene variables inside of our game scene. So to do that, we will need to grab our ball for the first two, our player paddle for the next one, opposing paddle for the next one, player score, and opposing score. And you can't just connect them like this. It doesn't quite work like that. To actually change their data, we have to do something a little different. We have to, oh, and also I'm going to select this input port and add a trigger input, which is that, we'll say game unpaused. So when the game's unpaused, it actually starts this flow. And so the first thing we need to do is, on the ball, select the nodule, drag it over, left click, and say R2D for rigid body 2D, we want to set position. And we very simply set that position to the ball position variable. Then we do the same thing, we simply say R2D, and we grab the velocity, so set velocity. And we drag this variable into this port. And now the ball will revert to its saved values every time we unpause, which was essentially the exact same place it was at when we paused. So, as you can probably imagine, we do the same thing for the paddles. So we'll grab the nodule, move over, R2D, set position, set it to the player paddle position. Same thing on the opposing paddle, R2D, set position, set the opposing paddle position. And then for the scores, same thing. In this instance, we're going to say, wait a minute. So in this instance, I think we can just actually, we don't have to get the scores. Okay, so instead what we need to do is set the scores. So I'll come over here and I'm going to alt drag them in here. Since these are just raw values, we can actually just set these manually. And we set the player score like this, and we set the opposing score like this. And then, sorry about if you can hear the dog lapping up the water behind me. So now what we're going to do is select our output port, and we're going to add a new trigger output. And this is going to be, we're going to say this is load completed, or loading completed. And from here, whatever our last port is, it actually treats the flow like this. And the same thing from game unpause, we go to our first port, and then we just very simply have to set up the control flow like this. So now what will happen is every time the scene loads, it will set all of these variables using whichever values we saved on the application side of things. So the next thing we need to do is actually save those values. So if I exit this, or not exit this, let's maximize this, use the breadcrumber to go back to the upper graph. I'll come back to this in just a second. The next thing we need to do is, whenever the player pauses, we need to actually do the save, which is basically the opposite of this. And for that, we come over to our player toggles pause group. And in here, I'm going to, or above here, I'll left click, right click, go to nesting, and create another subgraph. Double click on the subgraph, double click on it again to enter it. It's going to be the same type of deal. Let's name it something. So let's say player pauses game. That's what triggers us off. So it's the same thing for the trigger. It winds up being the same thing for the trigger. Input name, player pauses game. And whenever the player pauses the game, what we have to do is we have to come into the scene and essentially do the opposite of what we just did, which is save certain values on our ball, our player paddle, our opposing paddle, and we need to save our current player score and our current opposing score. Let me drag these up. So now that we have these values, we have to actually save them to our application variables. So I'll come over here and I'll alt right click all 5 of these in so that we can set them. Or excuse me, in this instance it's all 6 of them. Zoom out a little bit, drag these down. Getting a little picky on the organization, but I'm going to do it anyway. And set up the control flow, which is very simple in this case. It's just one to the next. As long as I can select the proper one here. And now what we've got is the complete flow to save these variables. So now we just need to make sure we grab the proper values. And to do that, we use our good old rigid body component. So we'll select the nodule on the ball, and we'll say rigid body 2D, R2D for rigid body 2D. In this instance, we need to actually get the position, not set it, so we'll say get position. And whatever that value is, we'll plug into the port. So now we'll do the same thing for the other values, R2D, get velocity. use the velocity value here. As for the player paddle, R2D get position, and use that value to save to the application variable. Same thing here. R2D get position, drag it into the port. And in this instance, since we're using the scene variables here as opposed to the application variables, we don't have to do any, I don't think we have to do an integer conversion, so we can simply plug these in. And an out is, so now essentially what happens is this saves all of these values. And since the scene transition comes after we do the save, we need to make sure that in our output port, we create a trigger output, which is save complete. So save completed. Minimize out. Oh, wait a minute, hold on. I need to make sure that the port gets connected, don't I? So make sure to actually connect the control flow. Then you can leave the graph. Then we need to, oh, actually I need the full screen and breadcrumb out here. Now we can come down here and drag this into this. So I'm going to scooch all these over just a little bit, and then reset up this flow to flow around it like this. So now we will make sure to save all of the relevant values every time we pause the game. Now that we have this set up to save, it's not completely done. There's a slight nuance we need to consider here. If we just go like this, what's going to happen is it's going to treat every single scene transition as an instance to load the data, which is not what we want, because when we start a new game, we don't want it loading the data. Whenever we exit the results screen, we don't want it loading the data. We only want it to load the data when the player has actually unpaused the game. So to do this, we have to do a little bit of logic up here. We also have to create a new variable. So under app, we're going to come down to new variable, and we need to name this something which is, I guess what we can call this is game was unpaused. And this is going to be a Boolean type. So what we have to do is we have to take this game was unpaused Boolean, and we have to run it through an if statement. So if in control, and go like this. In the event the game was unpaused, that is when we want to run our game unpaused subgraph. So the first thing we need to do is check if the game was unpaused. If it was unpaused, we want to run our load game data on unpaused subgraph. However, if the game was not paused, we just very simply want to set the ball to its initial velocity from the center of the screen. And I'm trying to, okay. So actually we didn't actually need this port here, but so this is essentially what we need. And in order to get this variable to change, what we have to do is we have to go into our other graph, the pause screen script graph, and full screen this. And essentially, before we transition into the game scene on an unpause, we just need to change that variable to true. So I'll come into the app variable. I will alt drag in game was unpaused in order to set the value. I will make sure that the control flow goes around this one. And I will come over here, and we have to set up a Boolean literal. So Boolean literal. And we need to set game was unpaused to true if we unpause the game. Oh, that actually reminds me of one more step we need. So now I will minimize the graph, close this, reopen the game scene script graph, full screen this. Whenever we actually grab this Boolean, once we've used it, we need to make sure that we actually set that Boolean back to false, so it doesn't just stay as true and always load every single time. So we will come up here, same thing, we'll type Boolean literal, and we are very simply going to reset this variable to false if we loaded the game. All right. Okay, there's there actually is one more thing. So I need to go back into the load parameter, and we need to remember that if we are loading the physical scores, the actual data scores, we also need to update the UI elements. So to do that, we need to come down here, left click to unselect, right click to open the fuzzy finder. Oh, and actually we don't need to do that. We can just come over here to UI document and left click and drag it in. Then grab the nodule, go over and type in UI d get root visual element. And we need to get our root visual element. Then we've got to, once again, query. So do a uQuery extension. And we're going to need 2 of them for each of the scores. So we'll go like this. Probably drag them up here to do something like this. And then they're going to use the same root visual element. They are going to flow like this, actually. So we can flow them in like that. And what we are changing is the player score and the opposing score. Then we have to go over here and make sure that we grab our label, and we need to set the text, not the name, set the text. I even wanted to type text name, or I even wanted to type in set name there. So it's the same thing down here. Label set text. And this is going to remember to update our UI every time the game reloads. So now that we have the score, and we want to update it, and it is a text, so we had this problem last time, so I'm just going to keep it simple and use the integer to string node. That way it won't futz about the, it's not going to futz about the value being an integer as opposed to a string. So now that we have this, we want to change the flow to go from the query to change it to string to set the text. So do the same thing up here. Set the flow up. And then this, after this text is set for the player score, we can set the flow up to go like this. And the last thing we're going to do is set loading to completed. Alright, so now this graph is ready to go for reloading our game, reloading all of our game values once we are done with the game being paused. So now I will close the graph, and we're going to give it one final check to make sure everything is working properly. So what I'm going to do is let both scores get to 1, and then I will, once both scores get to 1, I will set up a pause. So the score gets to 1, I'll move it to the bottom and I'll pause real quick. And if this worked correctly, when I go back into the game, the paddles should be in the same spot, the ball should be in the same spot, the score should be in the same spot. So if this worked correctly, when I unpause, what's going to happen is the ball is going to score and it's going to show a victory. Alrighty, there we go. Thank you very much, thank you very much, thank you very much. Alright, so that is, there you go. That is actually the completion of the game, Pong. So from the victory screen, we can click return to start. We can start again. We can double check that the player can lose. So this instance it says defeat. And actually I need to double check, was the player getting scored correctly? So 1, 2, victory, okay good. So yeah, and so that is actually everything. We now have functioning Pong that scores and actually attributes winning and can pause, has UI, start screens, end screens, and everything works properly. All right. So that was everything, and I'm very sorry. This video is almost at 1 hour and 5 minutes, and I studied multiple times before I did that, so even after studying, it wound up taking forever to do that. I'm thinking in any future content I do, I will very likely not commit to like 3 videos off the top, because all 3 of those videos probably could have got split up into like at least 5 or 6 videos. to be consumed a little easier, so I'll have to consider that for next time. But for now, this video is actually done. And this Pong creation series is now complete. If you have liked what I've done so far, if you're into what I'm doing, please like, share, and subscribe this content. These things can save new developers a ton of headaches on trying to learn how to do this stuff. There's a lot of learning I've actually managed to do for you and compacted into these videos, so they can be useful. If you're really feeling up to it, I would love and I could really use your support on Patreon. That could help me become even more focused on getting more of this kind of work done. There are no more videos left to do for this series. I am considering doing a post-mortem vid where I just kind of do like an interview on camera of some things I learned throughout the series. I am also considering adding 3 bonus videos where I use Subgraph to add a little bit more visuals to the game. I'm thinking about using the visual effects graph to give the game a couple particle effects, like a trail on the ball, and then like maybe tiny trails on the paddles moving, and then anytime the ball collides with the surface, have a little particle effect. Pretty straightforward for particles. It'll be pretty straightforward for shader graph. I'll just do like some light custom shading on like the background and the different objects. Won't be too complicated. And the very last bonus video will be a video where I use FL Studio and an FL Studio synthesizer to make a few sparse sound effects for the game. So maybe some like response sounds for like whenever the player clicks buttons. Maybe some sounds for every time the ball bounces off the surface. A score or a sound for every time the ball hits a goal, and then maybe like a little victory tune or something like that. It's just something to play around with, creating some sounds using a synth. So I haven't decided if I'm going to do those bonus videos, but if I do another video series after this, like a Pong follow-up, something like a Tetris series, it would be nice to have the shader graph, visual effects graph, and a few sound effects under my belt to finish those games up. So I'm considering doing the bonus content for these videos for the Pong series to kind of brush my skills up that much further. So since this video has already taken an hour and almost 10 minutes, and if you bothered to stick with it this long, I really do appreciate it. Make sure to check out the post-mortem video, which will come either way, and if I do the bonus content, do not be afraid to check out the bonus content. Thank you for watching this video. Take care.